Okay, everybody, welcome. Glaciers. Here we go. There are two main types of glaciers. There are two main types of glaciers. The first one is a continental glacier, or also called an ice sheet. And as you can see in this diagram here, quite large, very large. This cover a whole or parts of a continent, hence the name Continental Glacier. The other type is called a mountain glacier or a valley glacier, and they flow in between in the valleys of mountains, sort of like a river of ice, they're often called. As you can see here, this is in the Swiss Alps. That's the second type of glacier. We'll learn more about these coming up. And I do want to point out, glaciers, when they move, they're not just ice. Along the way, they pick up a lot of sediment, all different sizes: sand, silt, clay, cobbles, boulders the size of a car, the size of this room. And this picture shows it quite well. Okay, you see this is the glacier ice that's melting here, and you can see all this sediment that it's carrying, and we're going to talk about how the sediment it deposits as well coming up. So let's start with some features of continental glaciers. Again, they're also called ice sheets. And here is this diagram here. It shows location on Earth today of pretty much the two continental glaciers or ice sheets that we have. And the biggest one is Antarctica, this continental glacier, and then Greenland is the other one. On the northern hemisphere, it's Greenland. And this is a diagram that shows during the last ice age, most recent ice age, that ended, I'm going to say, we usually use a time of around 10,000, 11,000 years ago is when it ended. And this is a diagram showing that continental glacier at its peak, at its height, when it was the largest. And as you can tell, it goes pretty much all of Canada and then down into the U.S. You know, we're New York, we're in this general area here, we were covered by ice. So where I'm standing right now, and if you're in New York watching this, where you are was covered by ice. And in general, the thickness of ice in, let's say, where I am right now, Glacier, New York, was about a mile thick. Over 5,000 feet thick is what it's estimated, which is really something to think about. That where you are was covered by a mile thick of ice, 20,000 years ago, 25,000 years ago. And I have it right here, written down, so it's clear for you to see. About 20,000 years ago, the height of the last glaciation, Glacier, New York was under ice that was approximately 1 mile thick. I do think that's cool to think about. And hopefully this will come out okay, but here you see a glacier that is retreating, a continental glacier that's retreating, and you can see there's lines of sediment here. These are called moraines, in this case end moraines, and it is sediment that was deposited by the glacier or kind of almost pushed, in some cases kind of pushed forward by the glacier, but long lines of sediment deposited by a glacier are called moraines. And some other features that we will see, kettle lakes here, these lakes are often a part of the feature, and drumlins are here. There's a drumlin field here. We'll look at those, and we'll look at eskers as well. There's other features of the continental glacier. This is in diagram form. It shows retreating glacier. Here it shows this moraine, this long pile, and they can be quite large. Here they're smaller, and I'll show you an example of that. Here is a partially buried ice block. We'll learn about that. And here is the outwash. This shows as far as that glacier got. All of this was all deposited by the water melting off of the glacier. And here, these bumps here are going to show drumlins is what they're trying to show. Drumlins, they're called. Okay, so now we're going to go into mountain glaciers, some features of mountain glaciers. Again, also called valley glaciers. And here's a good picture of one. Again, they often call it like a river of ice that's flowing between these mountains in the valley. And they all move slowly. It moves slowly downhill. And you can see these lines of sediment in there because, again, a glacier is not just ice. It has a lot of sediment and rock pieces that are in there that it will deposit when it melts. Here we can see a retreat. This is in Switzerland. Retreating glacier here. It's melting back quite a bit. So it's not that large anymore, but what you can see here, hopefully, is on the side, you can see moraines here of all of the sediment that had built up. Quite some pile. These are called lateral moraines because they're on the side, but any line of sediment deposited by a glacier called a moraine. Okay, and here we can see a diagram here of a mountain glacier. The main glacier here, and then these other glaciers kind of flow into it. It does flow like water, but very slowly. And I do want to point out that the valley that it will carve is very U-shaped, and we'll get to that later, U-shaped. And here are just some features. Moraine, I know I mentioned it already, but a moraine is a large line of sediment deposited by a glacier. Here are some examples. This is a mountain glacier. You can see it close up. Is that as it rubs up against the rock walls, sediment will fall into it from the rock walls, and it will like pluck pieces off of it. And you can see these long lines of sediment here that go off. And then when this glacier melts, all this stuff just drops right down, and it will cause a long line. Let me see what else we have. Here we have more. This is in Alaska, and you really can see the moraines. There's a lot of sediment there. And again, when these melt, these can be piles that are 50 feet high, or as you can see, even more so. Lateral moraine here, a lateral moraine here. This glacier was much larger, and then as it's melting, this stuff is all just dropping and getting dumped, basically. And I do want to point out how big these moraines can get. During that last ice age, when there was a large continental glacier, like I showed earlier, this was pretty much the extent of how far the glacier went. So the end moraines of those glaciers, there's a series of them. Basically, it makes up Long Island. That's what Long Island, New York is. You know, about 100 miles long, and pretty much it's all glacial sediment. And you can see how it goes out even into Cape Cod is also. So this is a glacier that size had a very large end moraine, which I think is pretty cool. Till. Now, till is a close-up of the sediment itself. This till is the sediment deposited by glaciers, and as I say right here, and the pieces of it, they're angular and unsorted. So each piece is angular, and they're all kind of mixed together in different sizes. As you can see here, maybe you can see it here. I'm not sure how well this comes out. You can see it, angular, sizes are mixed. And it's angular because these rocks they fall off or get plucked out of the bedrock, and they freeze into the ice, and then they kind of stay there for quite some time as they get transported. They don't have that tumbling and rolling that you see at the ocean or in a stream to get rounded, so they're angular. You can really kind of see it here, angular, all different sizes mixed together, because these rocks that fall off a glacier, they're all different sizes, they get frozen in there, and then they're all mixed together, and when the glacier melts, they all just drop. So angular unsorted is key. Make sure you know it. Angular unsorted. This, you really see this pile here. This is a pile deposited by a glacier, and again, angular, unsorted. Some of these can be quite large. These can be pieces, the size of a car, down to, sand size or even smaller. This is a close-up of this piece here is probably maybe about this big, and it shows that it is really scratched. What happens is some of these pieces of rock will actually get frozen in the side of a glacier or the bottom, and it will rub against the rock as it goes over it. And as that happens, it will create scratches in the sediment. And so it gets deposited and has those scratches. Not always, but that often happens. Can you find a piece? Not all glacial sediment actually has these scratches in it, but that tells you that it definitely is. We'll talk more about that in a little bit. A drumlin is a feature for glaciers. It's an elongated hill of sediment that basically has been run over by a glacier. Okay, so it was a pile of sediment that was deposited under a glacier, and the glacier runs it over and kind of stretches it out in one direction. Great picture of a drumlin here. And you can see how this is the steeper side, and then this is much more gradual. And the arrow in here shows the movement of the glacier in this case. It moved this way. So it was a pile like this, and the glacier moved it over. Okay. Sometimes it's hard to tell. This is good, but sometimes it's hard to tell whether it was moving this way or this way. But I think clearly the glacier, it's clear to see that the glacier did not move that way or that way, because it's not going to have a stretched out pile in that direction. And they usually occur together. Here you can see them kind of an overhead view, kind of like from space, and you can see the glacier probably moved this way, maybe this way, but definitely not that way. Right? The glacier is not going to stretch out lines in that direction. So it does show glacial movement. This one too, direction of ice flow. Again, you see 1, 2, 3 clear drumlins here. You see some off in the distance. And in this case, the ice flows this way. Again, as I said, the glacier ice was not moving that way. Here we see some more, and we see that the direction of the glacier was most likely this way. And these are continental glaciers that form these for the most part. And you see large fields of them, where sometimes there could be thousands of them together. Very cool. Here are some more. This is in Canada, and again, you see them here, here, here. Glacier moving that way. Most likely, yes, most likely that way. Maybe that way, not that way. An erratic, a glacial erratic, is a large boulder deposited by a glacier. We got to see some pictures of these. Here we go. Large glacier, middle of a field. It is kind of erratic at how this large rock is in the middle of this flat field. Where did it come from? Here's another one. This is in New Jersey. And here's another one. The car in there for scale. It's great. And sometimes this is flat. And the rock, the rock is very different than any other rock around there. Like this rock type is, this rock probably came from 300 miles away. How did it get here? Well, this large rock fell into a glacier, or got pulled out of a wall from a glacier, and the glacier can move such huge rocks. And then when that glacier melts, it just gets dropped right there. Glacial erratic. Okay? Here we go. Glacial outwash is sediment deposited by the meltwater from a glacier. So now this is where it gets a little more complicated, because unlike glacial till, this sediment is smaller and sorted, usually sand size. So, if you look at this picture here, the hole-in-the-wall glacier, which is in Alaska, this glacier is kind of melting back, and a lot of water is coming off, and this water is then Okay, we're back after a little technical malfunction. Here we go, back at the hole-in-the-wall glacier. As I was saying, what you have is the glacier here is melting, and a lot of water is coming off the glacier. And that water is going to carry some sediment, but it only carries smaller sediments. That water cannot move boulders that are this big. It's more just sand, mostly sand and silt, and that all comes out here. And when it comes out here, it ends up being really flat, and all that sediment gets deposited really flat. That's called glacial outwash. So glacial outwash is, as I said before, sediment deposited by the water of the glacier, and it tends to be really sorted. Sand ends up being really flat. This is called an outwash plain. Outwash plain. Okay? This is another picture that kind of shows the outwash plain. Again, with so much water coming off, it has so much sediment in it, it all gets deposited here. So it really kind of, we say like it's a sediment-choked stream. All the sediment gets deposited, and then the stream has to go around it, and so it ends up being, we call what's known as a braided stream. Like when you braid someone's hair, right, how the stream kind of goes in and out like this. So braided stream is in the glacial outwash plain. Sediment deposited by the water that melts off a glacier. Okay, esker. We have an esker. Commonly, when you have a glacier, there's a lot of water melting off a glacier. Even in really cold times, water is always melting off, and often makes it down to the bottom. Sometimes it melts through the glacier. So sometimes you could have flowing underneath the glacier, you have like a river flowing underneath the glacier, and it will actually melt like a cave-like channel underneath the glacier, and the water will flow and be kind of constricted in this channel. And therefore all the sediment that's also in that water is also constricted to this channel, and it will build up in the bottom. So it will kind of almost fill in this cave-like channel. And when all the glacier is gone and completely melted, you're left with this sort of sediment that filled up this cave-like channel, and it's called an esker. It's really cool. Look at these pictures. I'm going to call it esker is a snake-like line of sediment deposited by water that flowed under a glacier. Check it out. Okay, so what you can see it. It goes right here, and then there's a road there, and it goes here. You can see it off in the distance here. And again, this was from underneath the glacier. You can see this is the same spot, but this is another angle. And it's cool to think about that this was underneath the glacier 25,000 years ago. It carved this cave-like channel, and the water was flowing through it, and it built up. And then it looks like this really unique feature. It's just one of those really cool things about earth science in general. And here's another picture of it here. Another picture of a different location. You see an esker here. It's pretty cool. If you look at it if you were there, it looks just maybe like a hill. You then pull out from overhead, you can kind of see it. You see maybe why I call it snake-like. Okay, next feature is this, a Kettlelink. A Kettlelink are small lakes formed by large ice blocks. Let's go to this. Check this out. Now here you can see, here's a retreating glacier, and it's kind of these large blocks. Now this is a person. I'm not sure how well you can see that, but this is a person right here. So this ice block is 30 feet tall, 35 feet tall. They can be quite big. And what happens is as this glacier's melting, you don't see it here, but a lot of water's rushing by, and what happens is that water will go by it, and will have a lot of sand type sediment in it and silt, and will build up around it, and they end up getting buried like this, or halfway buried. And then at some point, it will take a long time at this point for the ice block to melt, but it will melt. And then when it melts, the water will all go on the ground, and this will sort of collapse. And then you have a sort of deep, roundish lake like that, and they're called a Kettlelink. Also really cool, and you can see them again in areas that were covered by lakes. And here's two of them right here. I think this is in Wisconsin, I'm not sure, but also formed, maybe it's Minnesota, also formed during the last ice age in which New York was underneath that Milo ice I spoke about earlier. Glacial striations, scratches and grooves in the bedrock. When the glacier moves, it has boulders and smaller rocks often frozen into the ice on the bottom and sides of it. So when it moves, it moves, and I heard it described as like ice-filled sandpaper. And it actually, those rocks in the glacier will scratch that bedrock, and it can scratch big grooves in that bedrock, creating glacial striations. And you can see them here. You see them how you go in this direction. Okay, they're all like this. So the glacier moved over, well, either this way or this way. We can't really tell from looking at it like this, as it went over the bedrock. Now what happens too, it is kind of smooth, because what you also have in there is the sand, and the smaller stuff acts like fine sandpaper, and the sand will kind of like, if you sand wood for a while, it does get excuse me it does get really smooth, and the sand will kind of smooth it out and sort of polish it. You see how it's kind of shiny here? It's like polished, and then the larger like rocks in there of your fist or bigger will create these grooves in there, which are again striations. This is in Alaska. Okay, you kind of see them here too. Now they're in a bunch of different directions. A little harder to see if this is in Canada, but again, it's also kind of has a degree of like polish to it, again from that sand. And this you can also see the striations go in this direction, but you get a sense of it is kind of smooth from the smaller sediment, which is cool. This one you really can see well. Here's a hammer here for scale, and you see the striations kind of in this way, but see how polished it is. Very cool. We do see this. We see this in New York, even close by, which is really cool. And mountain glaciers, a key thing about mountain glaciers is that they form, that the valleys that they will leave behind are unique in that they are shaped like a U. They're U-shaped valleys. Rivers have V-shaped valleys, but glaciers form U-shaped valleys. We got to look at them. Here we go. As we saw this earlier, this is what a glacier does. It's removing a lot of this rock of the bedrock. It's plucking it, it's taking it out. U-shaped valley. So when it melts, what you're left with is this. You see how U-shaped this is, and U-shaped here. You see U-shaped valley, glacier. V, if it's pointy down here, that's a river. And here we have some real life pictures of it. This is in Colorado. This is a nice U-shaped valley here. That's a really good picture of it. And then this one is another really good U-shaped valley. That's a classic U-shaped valley formed by a glacier. Know that for sure. Glaciers, U-shaped valley. Well, what valley does the glacier form? What shaped valley? U-shaped. Know it. Okay, so thanks for watching, and from all of us here at Gazdonian Productions, hope you enjoyed learning about glaciers.